Hi, everybody. Welcome back to podcast episode number 5 from Global Satellite Engineering. I'm Rene Winter. We're here with Jeffrey Palmer. And whether you're in mining, agriculture, conservation, maritime, fleet management, lone worker solutions, or you're just a tech enthusiast, this podcast is for you. We're here to explore cutting edge technology, how it's transforming industries, and how we can make the impossible possible. So please follow us on GSE across all of our social pages. Ask us any questions, reach out what you'd like to hear from us, bring us your need or your solution inquiry, and we can advise and guide you on the best network to be using, the product that suits your use case, or anything that you require in between. So last week we had a really good informative summary of all the different networks and how they work and what they've been doing for the industry. So today we're going to go a little bit deeper into the actual products that work on these networks. And Jeff, we've got such amazing things happening at the moment. We've got the ST9101 that runs on Viasat. We've got our own in-house OEM products that we've designed and developed, the GSAT Solar and the GSAT Micro Core that work on the Globalstar network. We've got the MCG101, which has an Iridium embedded chip, and we've got all these great partners with all these great products. So please tell us a little bit about each of them, how they work for different solutions, and what makes them beneficial on the different networks.
Yeah, absolutely. Thanks, Rene. Let's start with the GSAT Solar. That's a very new product and new capability that utilizes the Globalstar network. It's unique because of its size and weight, right? We're talking about a tracking device that is a total weight of 2 grams, and that includes the antenna for transmission, reception of GPS, battery charging, solar panel, casing, a waterproof package. All of it is a total weight of 22 grams. Now, there's inherent limitations in size, right? You don't get high bandwidth, you don't get high position reporting rates, right? It's designed to be a few times a day location tracking device that fits on equipment, towables, animals, collars, just a variety of solutions that you need a few positions a day for valuable information of that asset. Now, that, as mentioned, that operates on the Globalstar network. There's a lot of creative things we're doing around that that we'll cover in more detail in specific podcasts, but it has a built-in accelerometer, Bluetooth. We can talk to a variety of things, even control external things and make decisions about those sensors or devices. Moving on to GSAT Micro, right? The bloodline of GSAT Micro that's initially designed about 15 years ago is an Iridium modem. We've really focused on developing the core of that into a flexible, programmable architecture. I don't want to lead too much into product that's coming out, but we've built it into a variety of customer applications already. That's a new core that answers all of the IoT solutions, but we can really rapidly deploy and develop a solution that runs on any satellite network using an embedded MCU. So it's really a core that's built to drive the MCU, Bluetooth, battery charging, all of the things that you always do on an IoT core. And that will play into, honestly, all of the satellite networks, right? So it's a very flexible platform. It runs Python. You can write sort of threads or programs that do your individualized tasks on it. It's inexpensive, small, embedded core that's just really easy to deploy into IoT applications. Well, I'm not providing too much information on that because we will present actual products behind it next as they come out. So don't want to lead too much into that. So then we have products that we support a lot, like the Orbcomm / Viasat ST9101. This is a dual mode satellite and cellular terminal that runs on 4G and satellite. And it has a Lua framework. So you write Lua agents that run on board the ST9101 and the ST6100 series. The ST6100 series is not dual mode, it's satellite only, but the same application core. And for the last 15 years as well, we've written a custom code and logic that runs aboard these terminals to satisfy customer needs, connect to RS-232, 485, CAN bus, IOs, analog inputs, 4 to 20 milliamp sensors, Modbus, the whole gamut of remote control or control at the edge sort of capabilities. and then packing all of that into useful payloads that go over the air. That product sits very well in transportation, driver logging, weight management, sensors, remote gateways, right? Things that transmit maybe up to, say, 100 kilobits a month of traffic fit really well into the ST9101 architecture, as well as we have a full internal engineering team that writes code for these customer applications all the time. And we also do cable designs for these for fitting into OEM applications. And any questions there? There's a lot to cover on the ST9101. Again, we'll dive deeper into that topic. MCG series, back to. Yep.
I think that's super important, though, what you touched on there about how customizable our products are, and also our engineering capabilities of what we can do to develop these for different solutions. So yeah, that's an important part that you noted there across all of the products and all the networks and our capabilities.
Absolutely. I mean, ultimately, we're an engineering company. We have all of the engineering team from PCB design, fabrication, end-of-line kits, right, all the way up to application layer. So, bring us a challenge. Always love a challenge, right? There's always some balance of product design versus quantity of that market solution, but that's just part of product design. Back to one of our internal products from GSE, right? The MCG series. There's been a number of MCGs over the years. MCG 108 and then 101, and then moving into MCG Beyond. So all of these are really a full Linux core that runs on a multi-core CPU that runs, say, a VoIP server at the edge, does edge computing, has interface to CAN, USB, Ethernet, Wi-Fi, right? So a really powerful core that is Raspberry Pi-like, but Raspberry Pi is not built for temperature and voltage ranges that you would use in industrial applications, right? But it's a flexible application core. And so we use a standard Linux kernel so developers can write code and run applications as root on the box. And so it's very easy, again, for OEMs and developers to get into SAT cell connectivity on a platform that they're familiar with. So as that product line continues to evolve, today the MCG 101 is delivered with an Iridium 9523 modem in it that can do data, SMS, voice, SPD, right, and do all of the connectivity that a application platform would do at the edge. And that will continue to move on to the MCG Beyond series, which, again, as the products come out behind it, we'll continue to talk about it, but a very exciting platform. Last, I'll touch quickly on Viasat FT2225. That is a small terminal that can do up to like 20 kilobits of connectivity on an omnidirectional antenna. It is IOs, as many of our other product lines do. It's meant to be Ethernet or Wi-Fi connected to be a transport layer, but it is a very cost-effective terminal for applications that are using between 1 and 20-ish megabytes of traffic a month. The power consumption, or actual wattage that the terminal consumes, is much, much less than, say, a Starlink KA/KU VSAT terminal, and it's easy to deploy and point, and has great connectivity throughout the Americas, Africa, Europe, and excited to develop some projects around that terminal as well.
Thanks, Jeff. That's a great download of all the different products that we have and the networks that they work on. And I'm looking forward to diving into each of those in a separate episode as we progress in our series. And I also like the fact that you mentioned edge computing so often. It was something that took me a while to get to grips with and understand. And I look forward to chatting to you next week, where we dive into what that edge computing is, how we process the data once it's hit the server and it sits on the back end, and how we can use that to create a nice dashboard for customers. So we look forward to chatting to you next week and going into some more detail on the edge computing of the products that we've discussed. Thank you.
Thanks, Rene.